All right, guys. So just kind of wrapping up our 10-3 notes. We got through about 2/3 of it yesterday, or probably more. Uh, so we are going to. All right, I am presenting. Yeah. Okay. Yeah. So we'll finish up that back page. So the only thing I guess that you really need to remember here is. That's different from what we covered yesterday is that, the distance formula kind of comes from the Pythagorean theorem. But if you want to get that straight line distance from the origin to any point on the coordinate plane, you take the square root of basically each one of your points squared. Okay, so let's do an example. And then we talked a little bit about this yesterday, how sine is y over, well, we said sine was just y yesterday, so we'll talk about what the r is today. Cosine yesterday was just x, so we'll look at kind of how that's a little bit different on this. And then tangent is the same as it was yesterday, y over x. So let's go ahead and plot that point in our example for -2, okay? All right, so we go ahead and plot that, and then we're basically looking to, find our trig ratios. So our trig ratios visually for what? All right, so we're looking. We're looking to basically kind of look at this as a right triangle with those kind of vertices right there. Okay, and so really we're looking for the trig ratios of this angle right here. Okay, and I know that's a little bit tough to see. Maybe I can zoom in. That might be a little bit better. All right, so basically here is what would be easy that we kind of already have. We know that this is 4. This is -2, and then we need to find out. Sorry, is it 4 and -2? Yeah. So then we need to find out what's the hypotenuse, right? So that's where we're going to use the distance formula on this. They call that value r. So r equals 4 squared plus, they say the absolute value of the point squared, but if you just even put it in as -2 squared, it's going to become positive anyways. So 16 plus 4 gives us 20. And then we want to just reduce that down to, or write it as a simplified radical as thinking 4 times 5, so 2 square roots of 5. So now we know that this length is 2 square roots of 5 units long. Okay. So just based on that, then we could put together just by looking at the triangle and not even following the formulas, we could put together our trig functions, right? So sine is always going to be opposite over hypotenuse. So -2 over 2 square roots of 5. And then we would need to actually rationalize that. So let's try to simplify that. So -2 over 2 is just going to be -1. I'm realizing I didn't do this on the notes. So could anybody rationalize that denominator for me pretty quick? Anybody remember how to do that from yesterday? What do I need to? Yes, go ahead. Square root of 5, yeah. So yeah, multiply by the square root of 5 over the square root of 5. So that would give me negative square root of 5 over 5. So that would be simplified form. Then cosine is going to be adjacent over hypotenuse. So 4 over 2 square roots of 5. So that gives me 2 over the square root of 5. And again, multiply by the square root of 5 over the square root of 5. So that gives me 2 square roots of 5 over 5. And tangent. That one's going to be a little bit easier because we have just our more normal looking numbers. So tangent is going to be opposite over adjacent. So negative 2 over 4. Or negative 1/2. Okay, so it actually says find the 6 trig functions. So remember how to find those inverses would just be to flip them. Okay, so so I'll go ahead and do that. If you want to try to do that on your own, you can, and then compare, or you could just follow along with me. All right, so they're up there. Whenever you're done, you can check those. It may be a good idea for you guys. Well, I think probably our time would be best spent if we didn't spend a lot of time on the next example. If you want to try that, I can give you the answers. But I think probably we're ready to kind of try to clean our plates for the most part on those Math Excel assignments. So why don't I go ahead and end the video there, and then I'll take questions. I'm going to highly recommend that you use this time where you could ask questions to work through 10.3, just because I think that's probably the toughest one. And hopefully you're done with most of 10.1 and 10.2. Yes. Yes, I will. Yes. You're welcome.